I hope I'm audible to you all, as well as screen is visible. Everybody, hello, hello, hello.
Yes, sir.
Okay. Thank you. Today we'll be dealing with the problem of IRC 37/2001. How we are going to arrive at the solution of it based on the IRC code, the Indian Road Congress, mentioned with the code number IRC 37/2001. In the last class, we were discussing about the VDF, which is nothing but it is a multiplier to convert the number of commercial vehicles of a different axle loads and axle configurations to the number of standard axle load repetitions, which means it is nothing but it is used to convert the given number of commercial vehicles of different axle loads in terms of the number of standard axle repetitions, the number of standard axle load repetitions. Okay, so you know that upon the given roads, okay, you do have the different types of commercial vehicles running with the different axle loads as well as different axle configurations. But in order to design the thickness of flexible pavement, we need to justify with reference to the standard axle load repetitions. Okay, so we know the standard axle load of 8 tons. So how many number of standard axle load bearing 8 ton do have the repetitions upon the given pavement surface, or the proposed pavement surface for which we are trying to design the thickness. Okay, that is going to be done by the use of VDF, which is nothing but the multiplier. Okay, for designing a new pavement, the VDF should be arrived at carefully by carrying out specific axle load surveys. As we had discussed in the last class, how we are going to do it, based on the axle load survey, we will be able to note down what is the amount of what can say what is the amount of axle load that particular vehicle is going to carry, and what are the different axle configurations that particular vehicle is going to possess. So some surveys have been carried out in the country on national highways, state highways, and major district roads, which reveal excessive overloading of commercial vehicles. Therefore, it is recommended that the designer should take the realistic value of VDF after conducting the axle load survey, particularly in the case of major projects. On some sections, there may be a significant difference in axle loading in two directions of traffic. In such situations, the VDF should be evaluated direction-wise to determine the lanes which are heavily loaded for the purpose of design. Say for example, as you know, in the Indian road conditions, you are going to experience most number of vehicles that are being overloaded, okay, beyond the axle load capacity of 8 tons. So hence we are going to do the axle load surveying for all the vehicles that are trying to run upon the national highway, state highway, major district roads, other district roads. Not other district roads, only these three roads of say for example express highways, national highways, state highways, and major district roads. These are of prime importance where most number of transportation is going to be carried out, or else most number of traffic is likely to be running upon it between origin and destination. Okay, carrying cargoes, carrying loads. Okay, between terminal stations. Okay, now your road should be capable of withstanding the stress, strain, as well as deflection whenever the loads of 8 tons or beyond that is going to be coming upon the roads. Okay, hence what we will be doing is we are trying to increase the axle configuration for all the automobiles such that the load carrying capacity of those vehicles will be increased by the basis of what you can say, just we had discussed about the ESWL concept as well as EWL concept, wherein with the increase in the number of wheels as well as with the increase in the number of axle configuration, the amount of load that is going to get transferred upon the road is not going to be just strained beyond 8 tons. It could carry 16 tons, 32 tons, as well as 64 tons. Okay, which is going to be greater than the legal axle load of 8 tons. But how are we going to compensate that? By increasing the number of axles. By doing so, 16-ton load is going to get reduced upon the road surface due to increase in the axle configuration. For each axle, okay, suppose if there are two axles, I told you during our discussion, suppose if these are the two rear end axles with the two wheels on both the sides, if a 16-ton load is going to come upon the road surface, then how it will be distributed? 8-ton load for each axle. I understood. 8-ton load for each axle. Again, for each wheel, under each wheel, what will be the load that could be carried out by each wheel? If this is 8 ton, 8 divided by 4, 2 tons each. Okay, so hence, though the vehicle is trying to carry the 16 ton under each wheels, it will be having a load of 2 tons. Okay, 2 ton each for each axles. Okay, so hence we are going to reduce the amount of load that is going to be coming upon the road surface due to increase in the, what you can say, traffic, as well increase in the axle configuration, as well as increase in the axle loads. Okay, based on the, what you can say, ESWL, EWL, as well as VDF concept. Okay, so hence you also be knowing that there are 2 lanes, 4 lanes, 6 lanes, and so on. In which of the particular lane the traffic is more significant moving? Okay, so that particular lane has to be designed with the sufficient design thickness. Okay, say for example, ongoing traffic, upcoming traffic. Okay, say for example, if there is a 2-lane road, okay, between Bijapur and Solapur, okay, most number of traffic that is going to be moving from Bijapur to Solapur. Okay, Bijapur to Solapur in the sense the left side lane. Okay, so most number of the traffic, if it is trying to move from Bijapur to Solapur, then they are going to make use of left side lane. Okay, but less number of traffic that is going coming from opposite direction, that is from Solapur to Bijapur, then it is considered to be a right side lane. So you are going to accordingly design the thickness of flexible pavement based on the predominant traffic that is trying to be moving from origin and destination, right? So I was speaking with respect to the 2-lane road, but you can just also consider that it is applicable for 4-lane road also. Okay, 4-lane road in the sense 2 lanes are going to be meant for moment of ongoing traffic, and another 2 lanes are going to be meant for opposite traffic that is coming from the opposite direction. Okay, so in which of these two directions the traffic is going to be more and predominant, I mean to say, where the traffic is going to be exceeding beyond the limitations, or where you can see much of the traffic that is going to be running upon it, as well as where do the lane is going to carry most of the loads, you have to assess it based on the axle load survey, depending upon which you will be able to decide which of the lane has to be designed with the maximum thickness, which of the lane has to be designed with the least thickness, without going for what you can say, the constant thickness that is going to be applicable for all the lanes. We are trying to design the thicknesses for those lanes which are going to be overloaded. Okay, which are going to be overloaded with the traffic running. Are you understood? Are you all getting my point or not? Okay, so that is how. Just a minute, please. Somebody's trying to enter this meeting. Am I audible, as well as this particular screen is visible to you all?
Yes,
Everybody?
sir.
Okay, so this is all about the video which is going to be useful for converting the different axle loads as well as axle config into standard axle load repetitions. Okay, we are going to see that how it is going to be done in the problem section. Okay, now wherever the VDF values are not going to be available due to, what you can say, when the project size happen to be very much large. Okay, where the sufficient information on the axle load is not going to be available, so it does not warrant conducting a axle load survey. So the indicative values of vehicle damaging factors which are going to be given in the table number 1 can be used wherever you cannot conduct the axle load survey. Okay, thereby you are going to make use of this particular indicative VDF value as per Indian Road Congress, as well as if the project size happens to be larger. So based on the total traffic, that is initial traffic volume, the initial traffic volume in terms of number of commercial vehicles per day, you can sufficiently make use of these values based on the terrain classification, like for rolling and plain terrain, and for hilly as well as mountainous terrain, what should be the values corresponding to the total initial traffic volume in terms of commercial vehicles per day. Okay, so how it will be significant as well as useful, we are going to look at it at the design stage. Okay, while we are going to solve the problem, numerical problem. Okay, now we'll be studying about the CF. We have done with this CVPD traffic growth, design life of the pavement in terms of years, vehicle damaging factor. Now we are going to discuss about the distribution of commercial traffic over the carriageway. Okay, what does it mean actually? Distribution of commercial traffic over the carriageway. A realistic assessment of distribution of commercial traffic by direction and by lane is necessary as it is directly affecting the total equivalent standard axle load applications used in the design. In the absence of adequate and conclusive data for Indian conditions, it is recommended that for the time being, the following distribution may be assumed for design until more reliable data on placement of commercial vehicles on the carriageway lanes are available. As you know that there are two lane roads. Say for example, there are two lane roads. Two lane roads means this is ongoing traffic and this is opposite traffic that is going to be coming upon. Okay, what is the width of the two lane road? It is, say for example, for single lane it is 3.5 meters, then for two lane is 7 meters. Okay, say what about the four lane road? What about the four lane road? Four lane road means there are two lanes that are being meant for ongoing traffic, another two lanes are meant for opposite traffic that is going to be coming from the other direction. Okay, this is ongoing traffic and this is the opposite traffic. Okay, this is ongoing and this is opposite. So what is the width of this? It is almost 15 meters, including 1 meter of width of what you can say divider section at the in between bit at the two lane roads. Okay, that is called as median. Okay, median in between what you can say four lane road, right? So here, say for example, with the increase in the lane distribution, say from two lane to four lane to six lane to eight lane. Suppose, if, for example, I'm going to consider 6 lanes. So what are you going to suppose here? There is an additional lane that is going to be constructed adjacent to two lane one way traffic. Okay, on either side. So how many number of lanes you can express here? There are 6 number of lanes. Okay, for national highway, express highways. Hopefully you can just had a scene about while you were moving towards some of the destination places, you would have encountered with the most number of roads where you had seen 8 number of lanes. Okay, most number of you people have seen 6 number of lanes. Are you understood? So what is the significance of that? Why that number of lanes are going to be increasing? Can we tell me? What are the significance or advantages why it is going to be increasing? Why only two lane is it not sufficient to get constructed between the original destination? Why is it not why is it not considered to be what can say prime importance to consider only two lane road? Why we have to go for the 4 lane road, 6 lane road, 8 lane road? Please tell me answer to this question. Hello, hello, hello.
Yes, sir.
Yes, please tell me why do the increase in the width of the road is going to be done from 2 lane road 4 lane, 4 lane to 6 lane, 6 lane to 8 lane? Why is it necessary?
So the traffic density will be increasing day by day, sir, these days.
Very good. So because of increase in the traffic, we are trying to increase the width of the road. Hence, none of the traffic is going to face any kind of difficulty while it's traveling. Okay. So for any kind of overtaking operation to be carried out, okay, it's not going to face any kind of troubles. Okay. So that is the one reason. What would be the other reason? What is the intention of making the roads to be one way instead of two way? Say, suppose there are 6 lanes. Just consider we are talking about the 6 lane road. 3 lanes are meant for ongoing traffic. Another 3 lanes are meant for opposite traffic. Could you tell me why these 3 lanes are meant for that particular traffic that is going to be moving from origin to destination? Another 3 lanes are meant for traffic that is coming from destination to origin. What is the reason?
So the travel time will be reduced if the traffic is separated.
Travel time is reduced. No, travel time will
And
increase, na? I mean, travel time. Okay. Travel time will reduce in the sense the speed of the vehicles will increase. Correct. You are right. Okay. The speeds of vehicles
even the
will.
accident will be reduced,
Very
number
good.
of
Excellent.
accidents.
Correct. You have answer to this question correctly. And what about the what can say the time that is going to be required for overtaking operations to be done? Okay, there won't be any necessity for traffic that is running upon one-way roads. Okay, there won't be necessity for those traffic to do the overtaking operation upon the one-way road. Okay, is it clear?
Yes, sir.
Overtaking operation can be carried out with with increasing number of lanes. What will be the what would be the what can say the uh, extent of overtaking operations to be carried out, or
It
frequency
will
of
be
overtaking
more.
operations to be carried out with increasing number of lanes?
It will be more, sir.
With
Chances are more for overtaking.
if number of lanes increases, then the tendency of overtaking operations will reduce. I don't understood, because even while during overtaking operation to be carried on one-way road, we are not going to face any kind of roads that are we are not going to be facing any kind of what can say vehicles that are going to come from opposite direction, as we could experience on the two-lane road. Okay, what would be the difficulty upon the two-lane road during overtaking the slower moving vehicle with a faster speed? If you are going to be moving in the faster moving vehicle, while you are trying to take the overtaking operation with respect to the slow moving vehicle, you would have experienced the opposite traffic that is going to be coming on the same lane. I understood, while you are trying to move upon the adjacent lane. I am trying to speak with respect to two lane road, but that difficulty is going to be solved while you are trying to consider three lanes meant for one way traffic. I understood. So hence the overtaking operation, the time which is going to be wasted during overtaking operation is going to be reduced. Are you understood? This is the second reason. And what would be the third reason? The third reason is very important and is very much considerable. What we are going to be discussing about the distribution of commercial traffic over the carriageway. You know that with the increasing number of lanes, what will be the occupancy of this traffic upon a single lane? Occupancy of the traffic upon the single lane, as you would have seen upon the road with a two-lane width. Hello.
The density will be reduced. It will be equally distributed in all the lanes.
Excellent,
Like,
excellent. That's what I was about to tell you with this concept of distribution commercial traffic over the carriageway. So, how do the traffic is going to get distributed above the lanes? Why? That's why what you can say the concentration of the traffic upon single lanes. Okay, even though if there are three number of lanes, okay, when it is going to be comparable with respect to two number of lane, the concentration of stress, okay, upon each lane is going to be more in the two lane road, but the constant stress, strain as well as deflection is going to get reduced with the increase in the number of lanes. So how what would be the percentage of what you can say extremity or damage that is going to be caused by the vehicles that are trying to move upon 4 lane road, 8 lane road, is going to be seen with respect to the distribution of commercial traffic over the carriageway? What percentage of traffic should be considered for damaging effect caused to the pavement is going to be studied under distribution of commercial traffic over the carriageway, right? Okay, now we'll proceed with this. Right. For a single lane road, traffic tends to be more channelized on a single lane road than the two lane roads. And to allow for this concentration of wheel load repetitions, the design should be based on total number of commercial vehicles in both the directions. Okay, in the single lane road, what usually is going to happen? The traffic is going to be more concentrated because of the traffic that is going to be running from both the direction. Hence, the traffic count could be taken not only for one particular direction; it should be taken up for the traffic that is going to be coming from the opposite direction also. So both direction traffic, the direction that is going to be running in both the directions should be taken into consideration for designing the pavement surface. Okay, for designing the thickness of the flexible pavement. Okay, so what about this two lane single carriageway roads? The design should be based on 75% of total number of commercial vehicles in both directions. Okay, so if there are any two number of lanes, for designing the national highway, what percentage of traffic you are going to consider for designing thickness of flexible pavement? It is only 75%. Suppose if there are 100 number of vehicles that are trying to move, okay, then 75 number of vehicles are responsible for damaging the road surface, especially while if it is considered to be a 2-lane road. Okay, whatever the designs that you are going to make or the thickness of a flexible pavement you are going to decide, it is based on 75% of total number of commercial vehicles in both the direction, especially if you are trying to construct the road for 2-lane roads. Suppose if you are trying to construct the 2-lane single carriageway roads. 2-lane single carriageway road in the sense, suppose there is no median in between. Okay, suppose if the road is going to have width of 7 meters. Okay, that is considered to be a 2-lane single carriageway. What do you mean by single lane road? Single lane road means, what is the width of this single lane road? It is 3.5 meters. What is a 2-lane single carriageway road? There is a single carriageway wherein there are two number of lanes without having any separation gap. Okay, so we are going to be expecting the traffic in both the direction. But so whatever the traffic that is going to be moving in both the direction, suppose if there are 100 in number, we are going to take 75% out of total count of the traffic that is going to be running in the both the direction, especially in the 2-lane road. Are you understood? Okay. In the both the direction, in the sense, ongoing traffic should be considered 75%, of coming traffic, that is opposite direction traffic, that is the traffic coming from opposite direction, should also consider as 75%. Okay, so that is about the 2-lane single carriageway roads. So 4-lane single carriageway roads, what does it mean? 4-lane single carriageway road, so what does it mean actually? Can you tell me what does it mean? 2-lane single carriageway road means what? Or 4-lane single carriageway road means what? Say suppose 4-lane single carriageway. So these are the 2-lane and these are the 2 lanes. Okay, 4-lane single carriageway. What does it mean? Suppose if there are 8 number of lanes. Suppose if there are 8 number of lanes like this. 1, 2, 3, 4, 5, 6, 7 as well 8. Suppose if I am going to call 4-lane single carriageway road, this is considered to be a 4-lane single carriageway. Okay, this is considered to be a 4-lane single carriageway, in which this could be called as 2-lane single carriageway, and this also could be called as 2-lane single carriageway, or altogether this is called as 4-lane single carriageway, wherein the traffic is going to be considered in 4-lane single carriageway. The traffic is going to be considered predominant in one particular direction. Are you understood? So in which particular direction? From origin to destination. Suppose if this is the traffic flow that is going to be moving in one particular direction from origin to destination, then the direction of flow, based on the direction of flow of the traffic as well as the width of the road, we are going to call that one as 4-lane single carriageway road. Is that understood by you all? Suppose, for example, based on the direction of traffic I told you, if for example the direction of traffic is going to be opposite for another 2 lanes which are going to be adjacent to the ongoing traffic. So what you are going to call this one as? Though there is a 4-lane, but you are going to call this to be a 2-lane single carriageway on both the sides. Are you understood? This is going to be a 2-lane single carriageway. This is a 2-lane single carriageway. 2-lane single carriageway with one-way traffic on both the sides. Are you understood? But if you are going to see the direction of traffic that is going to be moving in one particular direction from origin to destination, this is called as, what is called as? 4-lane single carriageway, wherein the traffic is going to be predominant, that is going to be moving from origin to destination. Okay, right? So based on this knowledge, what we are going to do is, the damaging effect which you can experience upon 4-lane single carriageway will not be because of 100% of vehicles that are trying to move. Instead, it is only based on 40% of total number of commercial vehicles in both the direction. as you had clearly stated, okay, for one of my question, with the increase in the lane, the distribution is going to be taking place with respect to the traffic that is going to be moving from either origin to destination or destination to origin. Concentration of the vehicles are going to get released with increase in number of lanes. Hence, what we are trying to do is, here in the single lane road, the concentration of traffic was 100%. In the two lane single carriageway, the concentration is only considered to be a 75%. Okay, 25% of concentration has been released, and we are trying to consider the concentration of what can say concentration of vehicles as only 40%. Concentration of vehicles upon each four lane single carriageway road is 40% in both the direction. Okay, 60% of concentration of stress has been released due to increase in the number of lanes from single lane to four lane. I understood. As and when the number of lanes increases, then the design of a flexible pavement what you are trying to require, or thickness what you are going to decide, it is not based on 100% of vehicles that could be moving upon the roads. It will be reduced from 100 to 75, 75 to 40, and we are going to see 40 to say suppose lesser than that also, because of increase in the number of lanes. I understood. Hence, what you can say, uh, the design should be based on 40% of total number of commercial vehicles in both direction for four lane single carriage road. But what about the dual carriageway roads? Dual carriageway in the sense, say suppose the design of dual two lane carriageway roads should be based on 75% of the number of commercial vehicles in each direction. Whatever I am trying to read, it is all about the guidelines which has been stated as per Indian Road Congress. Okay, for dual three lane carriageway and the dual four lane carriageway, the distribution factor will be 60% and 45% respectively. I would like to tell you what do you mean by dual carriageway. Say suppose let us talk about the dual two lane carriageway roads. Okay, dual two lane carriageway road means this is dual two lane carriageway road. There is a presence of four lane. Hopefully you can just see, this is one lane, this is two lane, this is third lane, and this is fourth lane. Okay, we are talking about the dual two lane carriageway roads. This is called as dual two lane carriageway road. This is dual two lane carriageway road, or it can also called as four lane roads. Okay, four lane road. It can also be called as four lane road or dual two lane carriage road. In this, what is going to happen is, in dual two lane carriageway, the two lanes are being meant for ongoing traffic, another two lanes are going to be meant for opposite traffic, right? Similarly, for the traffic whatever trying to be moving upon this particular dual two lane carriageway, it is not like, say for example, single carriageway road, in which the total number of commercial vehicles in both directions should have been considered for designing the thickness of flexible pavement. But here the design thickness of flexible pavement is going to be decided based on only 75% because of increase in the lane from single lane road to two lane road. And usually we are considering what you can say, the traffic in one particular direction, not in the both the direction. But in the single lane road, the traffic was considered in both the direction. See here, the commercial vehicles, because of single lane road, you would have concentration, you would have assumed that concentration of wheel load repetition as well as design should be based on the number of commercial vehicles in both the directions. Okay, on single carriage road. But here the direction of the traffic is opposite on the other side, but there also will be expecting to have the two lanes. Okay, this is origin to destination flow, as well as the other direction of flow of the traffic will be from destination to origin. Hence, the concentration of stress, deflection, as well as strains upon the road surface is not based on 100 number of commercial vehicles, 100% of vehicles that are trying to be moving. It is because of 75% of commercial vehicles that are trying to move from origin to destination. Instead, suppose if there are 100 vehicles that are moving, we are trying to only consider 75 number of vehicles, or the damaging effect is being reduced because of increase in the number of lanes, because those vehicles are going to get shifted from lane 1 to lane 2, lane 2 to lane 1. Are you understood? Hence happen localization of the loads or wheel load axle configurations are not going to be uh, focused on one particular point. It is going to get distributed in the lateral direction. Okay, hence what you can say, the percentage of vehicles that are considered will be lesser. So for dual 3-lane carriageway, what does it mean? Dual 3-lane carriageway. This is a dual 3-lane carriageway. There are 3 number of lanes in both the direction. 3 lanes are meant for ongoing traffic. Another 3 lanes are meant for opposite traffic. This is a, what is this called as? This is dual 3-lane carriageway. So in this condition, these 3 lanes, if they are being meant for ongoing traffic, another 3 lanes are going to be meant for opposite traffic. Totally cumulative is called as 6-lane road. Otherwise, this could also be called as dual 3-lane carriageway. Either you can call this one as 6-lane road or dual 3-lane carriageway. For that dual 3-lane carriageway, the what you can say, distribution factor what you are considering is going to be referred as 60. The distribution factor which you are going to consider for the dual 3-lane carriageway is 60, and for dual 4-lane carriageway, whether the distribution factor will increase or decrease, it will obviously decrease from 60 to 45. Say suppose dual 4-lane carriageway, what are you going to call this one as dual 4-lane carriageway with other name? Can you tell me? Dual 4-lane carriageway could also be called as, hello, hello, does anybody hear me?
4-lane.
For dual 4-lane carriageway, suppose if there is a dual 4-lane carriageway, say for example, this is a dual 4-lane carriageway, 1, 2, 3, and this is 4. Okay, there are dual. Dual means what? 2 number of times. Dual, duplication on both the direction. Okay, for dual 4-lane carriageway, what is the other word that I can make use of it? When I said, say for example, dual 3-lane carriageway could also be called as 6-lane. Dual 2-lane carriageway can also be called as 4-lane. Here, dual 4-lane carriageway could be called as
8-lane.
very good, excellent. This could be called as 8-lane. Either it can be called as 8-lane or else dual 4-lane carriageway. 4 lanes are meant for ongoing traffic. Another 4 lanes are being meant for opposite traffic that is going to come from destination to origin. So what is the distribution factor? Initially, what was the distribution factor or the total percentage of vehicles that could be running upon the dual 2-lane carriageway? It was 75. When you can expect to see the 4-lane road or dual 2-lane carriageway. And what would be this one? For 6-lane road or dual 3-lane carriageway, this has got reduced to 60. And when you can see additional amount of lanes, additional number of lanes, say from 6-lane to 8 lanes, 2 number of lanes have been added. So hence the commercial vehicles distribution factor has got reduced to 45. Okay, so from 4-lane road we construct 6-lane, from 6-lane road we have constructed 8 lanes. So this 4-lane could be called as dual 2-lane carriageway, dual 2-lane carriageway, and here 6-lane road can also be called as dual 3-lane carriageway, dual 3-lane carriageway, and this could be called as, though if it is 8-lane road, it is called as dual 4-lane carriageway. Dual 4-lane carriageway means 4 lanes on both the sides. Dual 3-lane means there are 3 lanes on both the sides. Dual 2-lane means there are 2 lanes on both the sides. Means totally together it could be either 8-lane, 6-lane or else what? 4-lane. Okay. So with reference to this assumption, we'll proceed further. How are we going to design the traffic? The design traffic is considered in terms of cumulative number of standard axles. I told you whatever the traffic that is trying to be moving upon the road, as we know in an Indian condition, the movement of the traffic is heterogeneous in nature with different axle loads as well as axle configuration. For that, what we should be doing is we have to convert them in terms of cumulative number of standard axles. How many number of accumulation of standard axle loads are going to be coming upon the roads? Because we know the standard value of the axle as 8 tons, standard axle as 8 tons. How many number of cumulative number of standard axles of 8 tons are going to be coming from different traffic of different axial configurations having different axial loads should be done by this particular formula. Okay, so during the design life of the road, as we have seen for the national highway, state highways, major district roads, there are different design lives of the pavement. Okay, so with reference to that, what should be the what can say cumulative number of standard axles that could be borne by that constructed road is going to be done by this following equation. N is equal to 365 into 1 plus, this is 1 plus r raised to n minus 1 divided by r into ADF. What do you mean by this? N is nothing but the cumulative number of standard axles to be catered in terms of MSA. Hopefully you can just remember the previous slide what we were talking about. We require the two parameters for designing the flexible pavement. Okay, one is design traffic in terms of cumulative number of standard axles, another is CBR value of subgrade. So we are talking about the design traffic in terms of cumulative number of standard axles. So for understanding this, we require the different parameters like A, D, F. We require, what do you mean by R? Okay, that's what we had said. What do you mean by A? There is nothing but initial traffic in the area of completion of construction in terms of number of commercial vehicles per day that we have studied, which is nothing but initial traffic after construction in terms of a number of commercial vehicles per day. We had understood what you mean by CVPD. Are you understood? And what is that another one? The lane distribution factor. Just now we had discussed about that. The distribution of commercial traffic over the carriageway. This is nothing but the lane distribution factor. Whether the given lane is single lane road, two lane road, four lane road, or dual carriageway road. Okay, this is the lane distribution factor. And what do you mean by F? Which is nothing but the vehicle damaging factor. F is nothing but vehicle damaging factor that we had studied. Okay, where is that? Okay, these are the values of VDF based on the IRC code. Okay, this is nothing but the concept which I discussed for the video. And N is the design life in years. N is the design life in years means for different pavement we have the different what you can say design life of the pavement. Say for example, national highway it is 15 years, express highways could be constructed for 20 number of years, and for other categories of roads the design life may vary between 10 to 15 years. Okay, that's about what you can say the value of N which you are going to make use of during computation of the design track in terms of cumulative number of standard axles. Okay, and R is nothing but the annual growth rate of commercial vehicles. We had spoken very much before. What do you mean by the traffic growth rate? Okay, traffic growth rate can be done by econometric models or by studying the past trends in the growth of traffic as per the growth in the population. Okay, so if the value of the traffic growth is not available, then you can assume that value to be 7.5%, right? So I'm going to first of all consider this parameter, design traffic in terms of cumulative number of standard axles. How are you going to calculate this? It is going to be represented as N, design traffic in terms of cumulative number of standard axles. For knowing the value of N, we require many number of parameters which has to be studied to be substituted in the given formula. Later on, we also require the value of CBR in terms of percentage of the soil subgrade. Okay, with reference to these two, there are many number of charts by virtue of which you can decide the thickness of flexible pavement, right? Say, just hope you are all familiar with this now. Okay, what do you mean by this? A is nothing but the initial traffic in the year of completion of construction in terms of number of commercial vehicles per day. How many number of commercial vehicles per day that are trying to be moving upon the road that we discussed, and what is the distribution of the traffic upon single lane road, two lane road, say 6 lane road and 8 lane road. We had seen what is the value of this vehicle damage factor. It is nothing but the multiplier that is going to be converting the different loads of commercial vehicles as well as axial configuration in terms of load repetitions made by what? Standard axles. Load repetitions made by standard axles upon the roads. And what is this R? Nothing but the annual rate of growth in the traffic, commercial traffic vehicles. Okay, which is considered 7.5%. And N is nothing but the design life. Okay, so with reference to this, we'll be solving a problem. Okay, there is another formula. The traffic in the year of completion is estimated using the following formula. That is A is equal to P in bracket 1 plus R raised to X, where P is the number of commercial vehicles as per the last count, and X is the number of years between the last count and the year of completion of construction. We are going to see this formula, which is not of that importance. Okay, when it's going to be applicable, we will justify it while we'll solve the problem. Okay, this is a problem very important in the examination. Definitely this problem is going to occur. Okay, you just have to focus upon this. Design the pavement for construction. For every highway engineer or the transport engineer, this particular problem is considered to be the only method by virtue of which they are going to design the thickness of flexible pavement, right? Design the pavement for construction of a new bypass with the following data. They are required to know the data pertaining to, say, whether the given lane is a 2-lane single carriageway, 3-lane single carriageway, 4-lane single carriageway. Say for example, if it is considered to be 2-lane single carriageway, what does it mean? 2-lane single carriageway. 2-lane single carriageway means this is the median, this is one-way traffic, and this is the other way traffic. I'm not talking about the 2-lane dual carriageway. I understood. You just can refer to 2-lane dual carriageway. How does it look like? Say for example, I am going to draw the 2-lane dual carriageway. What I told you, dual means a replication on the other side. 2-lane dual carriageway means this is called as 2-lane dual carriageway, where you can assume 2 lanes are meant for ongoing traffic and other 2 lanes are meant for opposite traffic. This is totally together called as 4-lane road. Either 4-lane road or else 2-lane dual carriageway road. Are you understood? And this is called as, what is this called as? 2-lane single carriageway road. Are you understood? Why it is called as 2-lane single carriageway? When you can say that single carriageway or dual carriageway, wherever, say for example, based on the direction of traffic, I told you, based on the direction of traffic, if they are having or traveling in both the direction upon the same carriageway, if the direction of travel is going to be done by the traffic on the same carriageway, say for example for ongoing as well as opposite traffic, with the width of say carriageway, let us assume this to be of 7 meters. 3.5 meters is meant for constructing a single lane road. For a 2-lane single carriageway, it is 7 meters. Okay, so if the direction of the traffic is predominant both the sides on same carriageway, that is called as 2-lane single carriageway. But here the direction of traffic is considered to be a one-way for 2-lane carriageway, and the direction of traffic that is going to be coming from opposite direction can also be considered as one way for the traffic that is going to be moving from destination to origin. For the traffic that is going to be moving from origin to destination, this is origin and this is destination, then the direction of traffic is considered one way on both the sides. Okay, on the 2-lane, then this is called as 2-lane dual carriageway. Okay, if the direction of traffic is not going to be segregated, if that is going to be just running upon the same carriageway width of 7 meters, that is called as 2-lane single carriageway. Okay, without going in deep with reference to what type of lane it is, we will solve this problem. We have only 5 minutes time. So the classification of the road is very important actually. Okay, what type of road you are trying to build is also very important, because based on the different types of pavement, the design life are going to vary. Based on the number of lanes, the distribution factors are going to vary. Are you understood? So what we require for this particular formula, we require A, we require D, we require F, we require R, and we require N. What do you mean by A? A has been given to us. What is nothing but initial traffic in the area of completion of construction, which is nothing but total amount of traffic flow that is trying to be running upon the roads per day, commercial vehicles per day. What is that? 400 CVPD. So what type of lane it is? It is 2-lane single carriageway. So what should be the distribution factor? What should be the distribution factor? Lane distribution factor that should be considered. We have spoken. So the lane distribution factor for 2-lane single carriageway road, it is how much? 75%. the design should be based on 75% of the total number of commercial vehicles in both the direction. Hence, they have considered the value of D as 75%. See here, distribution factor 75% means 0.75. Okay, and the rate of growth in the traffic per annum, wherever it is not going to be given to us, I told you to assume it to be 7.5. The traffic growth rate is 7.5. That is the value of R. Okay. The design life of the pavement, what type of pavement it is? It is a bypass. For example, we are usually considering that to be a national highway. So for national highway and state highways, the design should be based on the life of the pavement. How much? 15 years. Okay, n value is 15 years. A vehicle damaging factor, the vehicle damaging factor that has been given to us, how much it is? This should be given to us in the problem itself. They have already given based on the axle load survey. Otherwise, this could be taken up with respect to the tabular column that has been provided by IRC for 400 commercial vehicles per day. Say for 400 commercial vehicles per day for plain and rolling terrain, what should be the value that could be considered? Can you tell me? Initial traffic volume in terms of number of commercial vehicles per day. How much is that word? The value that has been given to us? Initial traffic in the year of completion of construction. There are 400 commercial vehicles per day. In which of the range the commercial vehicles are trying to fit in? 400 is coming in between 150 as well as 1500. Corresponding for rolling and plain terrain, the value of the VDF is considered to be 3.5. But as per the axle load survey, they had already given to us the value of VDF as 2.5. Those table which I have shown you could be referred only if what you can say, whenever it is not possible for you to conduct the axle load survey, the indicative values of the vehicle damage factor table 1 may be used, or wherever the project size happen to be very much enormous or large, where you cannot carry the axle load survey, or the sufficient information of the axle loads, what you can say, video factors could be assumed from this tabular column. But if they had already given to you, then no problem at all. Design value of the CBR of the subgrade soil. Here comes where the another parameter is very much important. Okay, what is that? Another parameter. The another parameter is the CBR value of the subgrade. So for whatever the input parameters which we have seen, it is used for a calculation of design traffic in terms of cumulative number of standard axles, which is nothing but the value of n that is going to be obtained by the substitution of the input parameters into the formula. But what should be the other parameter that should be given to us? The CBR of the soil subgrade. Okay, that has been given to us in the problem itself. Otherwise, we can say the practical conduction should be carried out. I mean to say, practical setups must be done for the soil for carrying out the or knowing the value of the CBR. Are you all say? I think there is another 10 minutes for me to complete this class. Am I right? Hello? Okay, anyways, quickly we're going to go through the solution part of it. Whatever we have seen, this is nothing but the given data. Are you understood? If the given data, say, for example, this should be given to you in the problem. Otherwise, you cannot assume this unless and otherwise you are going to go for doing the actual survey work of traffic count in that particular locality or roads. Okay, and design of CBR of the subgrade soil should be given to us in the problem itself. And if the vehicle damaging factor, if it is not going to be given, suppose if they had given to you, no problem. If it is not going to be given, accordingly, based on the value of this, based on referring to the value of that particular tabular column, this could be well known to us, or this could be referred. Either it might be 1.5, 2.5, or 3.5, whatever it might be, based on that particular table which I have shown you in the previous slide. Okay, suppose the traffic is consuming 150 CVPD commercial vehicles per day, then the VDF value happened to be 1.5. Now the traffic is consuming 450. If the given value is not been provided, I mean to say, if the data has not been given to us for 400 commercial vehicles per day, you could have assumed it to be 3.5, but the data has already been given to us as 2.5 standard axles per commercial vehicles. Okay, this is nothing but the multiplier. VDF is nothing but the multiplier that is going to be used for converting the different axial loads as well as axial configurations in terms of the axial load repetitions, standard axial load repetitions. Okay, how number of times the standard axials per commercial vehicles are going to get repeated upon the roads? It is 2.5 number of times. Are understood? Based on the commercial vehicles that are going to be running upon the roads is going to be understood. Okay, what is the distribution factor which we have seen? Say for a substitution into this formula, n is equal to 365 into 1 plus r s to n minus 1 into a into d into f divided by r. So we have the value of a, which is nothing but 400. We are going to know about what is lane distribution factor from the assumption. For two lane single carriage way, it is 75%. So hence we are considering distribution factor as 0.75. And cumulative number of standard axles in terms of the design traffic in terms of cumulative number of standard axles. Design traffic in terms of cumulative number of standard axles could be calculated based on this formula by substitution. 365 into 1 plus r. What is r? The value of r has been given to us. This is nothing but the r. 7.5% means 0.075 raised to n. N means the design life of the pavement of national highway is given as 15 years. This is the value of n. Okay, minus 1 divided by r. R is again how much? The traffic growth rate per annum. It is 0.075. A is how much? 400 commercial vehicles per day. And D is nothing but the distribution factor, which we have assumed to be 0.75. And F is nothing but what? How much is the value of F? That has been given to us. It is 2.5. Vehicle damaging factor, it is 2.5. After having calculated the value of this n, we are resulting the value to be this is the value which can assume. So in terms of standard axles, million standard axles, in terms of million standard axles, okay, what will be the multiple of 10 here? 1 2 3 4 5 6. So multiple of 10 could be called as what? Multiple of 10 will be called as million. 10 to the power of 6, 10 to the power of say minus 6. What is this called as? Is it 10 to the power of minus 6 or plus 6? 10 to the power of 6. This particular 10 to the power of 6 will be called as million. Okay, which I am going to convert this value in terms of 7.2 million. This SM is standard axles. I understood. I have converted the cumulative number of standard axles in terms of MSA. The cumulative number of standard axles could be calculated by expression n is equal to 365 1 plus r raised to n minus 1 divided by r into ADF. Very simple formula. Okay, from which we are converting the different cumulative number of standard axles in terms of million standard axles. Okay, in terms of 10 to the power of 6. Okay, next, the prime duty of us is to find out the thickness of flexible pavement based on the two parameters. So before that, I would like to tell you these are the design charts which IRC 37/2001 is going to be providing us. Okay, what is going to be varying? I told you the value of CBR is going to get ranged from 2% to 10%, like 2%, 3%, 4%. Okay, so on up to 5%, 6% till 10%. Okay, right, till 10%. So what will be the design traffic in the range of 1 to 10 MSA? This is a tabular column, or we can say pavement design catalog for the design traffic that is ranging between 1 to 10 MSA. So how much is the value that we had obtained as a cumulative number of standard axles? It is 7.2 MSA. Is it coming in between 1 to 10 MSA? Am I right or not? Whatever the calculation we had did, okay, the value that we have resulted, it is 7.2 MSA. So the range of the traffic that has been given to us is 1 to 10 MSA. Okay, whether that 7.2 is lying in between 1 to 10 MSA or not? Yes, but what is the value of CBR that has been given to us? It is 4%. So should we refer to this catalog? No, we are not going to refer to this particular catalog because the CBR is 2%. Next, go to the next slide. Okay, here it is 3%. We are not going to refer to this slide. we are going to refer to this particular slide. Why? Because the traffic is in between range of 1 to 10 MSA, as well as the CBR given happen to be 4%. With reference to this particular catalog, we'll be able to design the thickness requirement. So again, here, what is the cumulative traffic in terms of MSA that has been given to us? It is 7.2. Am I right? After the calculation, we have yielded the value as to be 7.2, which is in between 5 as well as 10. Okay. What is the total pavement thickness? Total pavement thickness has to be interpolated between 620 as well as 700. Are understood? Because 7.2, which lies in between 5 and 10. The total pavement thickness has been given to us directly in terms of mm. Okay, which is in between 620 as well as 700. And directly they will be giving us what are the thickness of different layers that should be used. Say we have surface course, base course, sub-base course. Okay, in that surface course we have wearing course surface. Okay, this was surface course, and we have binder course surface. So in the surface course, again, in between these two values we have to interpolate. In between these two values we have to interpolate. And for a granular base course we have to interpolate, and for a granular sub base course we have to interpolate. Are you understood? So definite value of the layer thickness of the pavement composition has been given to us. Based on what do you mean by that? Based on the input parameters. Very much important two input parameters. Which are they? Cumulative traffic in terms of MSA, which you're going to decide based on the value of N. Okay, based on the substitution of the input parameters in the formula N, we are going to obtain the cumulative traffic in terms of MSA. Okay, later this value of CBR in terms of percentage. We are going to choose what pavement design catalog chart has to be referred, as well as we can easily take into consideration what should be the total pavement thickness and what are the different layer thicknesses. Okay, here that is what they had did. Say total pavement thickness for CBR 4%. Total pavement thickness for CBR 4% and traffic 7.2 MSA. Okay, from figure 1. See, this is from plate number 1. Okay, they have taken it to be how much? 660 mm. Okay, what does it mean? This is 660, which is in between 620 and 700. I don't know whether you know whether you know about the methodology for interpolating values or not, but it can be calculated very easily with the help of your calculator. Interpolation can be done very easily with the help of your usage of your calculator. Okay, next, pavement composition interpolated. Okay, pavement composition interpolated for the value of the CBR 4%. Bituminous surfacing is considered to be 25 mm SDBC, 70 mm DBM. What about this SDBC? What about this DBM? We are not bothered about it. Why? Because this is going to be called as semi-dense bituminous concrete, and this is going to be called as dense bituminous macadam. Already by the pavement catalog, it is going to be very clear to us. This is 25 SDBC and this is 40 BC. Are you understood? Are you understood? Say for example, if I'm going to consider the cumulative traffic in terms of MSA as 5. Okay, what is the value of a wearing course? 25 SDBC, and binder course is considered to be 60 dBm. 25 SDBC, 60 dBm, right? That's what they had written. 25 SDBC, 60 dBm. Why not 60 dBm? Because the given value of a cumulative traffic is in between 5 to 10, which we have obtained is 7.2. After interpolation, we could get the value of dBm as 70. Okay, that you can do it by your own. What is the road base? What you can say base course thickness? Base course thickness, it is 250 mm. Base course thickness after interpolation also you will get it as 250 mm. And what is the value of granular subbase course? After interpolation you will be getting the value in between 285 as well as 330. Okay, that we are going to obtain as 315. Are you understood? This is subbase course. Okay, this is the value of subbase course. 315 is in between 285 as well as 330. You can just do this exercise for the next example, which is available in the IRC 37201 in my slide or presentation, which I have already shared in the Google Classroom as well as in WhatsApp. group, you can refer to this particular PPT for understanding or referring to the solution to this problem of bypass, as well as there is a next example for it is proposed to widen an existing 2-lane national highway section to 4-lane divided road. So from 2-lane road they are planning to go for 4-lane road. So they are asking to design the pavement for new carriageway with the following data. The data has been given to us. How are we going to solve that? We have to see by referring to the slide. Okay, we'll discuss about this solution in the next class. What we did it in the today's class is we have got to know the total overall thickness of a pavement as well as the thickness of pavement composition in terms of bituminous surfacing and base course as well as sub base course. You need not worry about that. Everything will be given to in the payment catalog. In the examination also these catalogs will be provided to you. Okay. Now why we have to refer to this traffic in terms of 1 to 10 MSA? Because there are another catalog that are ranging from 10 to 150 MSA for the CBR values that are likely to get varied from 2% to 10%, like 2%, 3%, 4%, so on up to 10% for the design traffic which is in the range of 10 to 150 MSA. Okay. So how many design catalog charts you can expect to see? 2, 3, 4, 5, 6, so on up to 10% of CBR for the design traffic 1 to 10 MSA. Another design category uh, another design category charts will be for traffic in the range of 10 to 150 MSA for the CBR value ranging from 2% to 10%. You have to keep it in your mind. Okay, so this is all about the IRC methodology for designing the flexible pavement. Okay, here we are going to end up our class. I'm going to take the attendance, please. Just a minute. Okay, thank you for attending the class, for kind patience. You can just exit the meeting now.